Ji, Assalamu alaikum to all the participants. I would like to thank all of you on behalf of SMEDA-UNIDO and Index for joining us today. As we have started a series of webinar with the USP Case Nest, and today's webinar is one of them. The title of today's webinar is Fuel Characterization for Boilers Feedstock, and the resource person is Dr. Asif Hussain Khoja Saab. He's a assistant professor at US Pakistan Center for Advanced Studies in Energy, NEST. He received his PhD in chemical engineering from University of Technology, Malaysia with distinction. His research focus is on waste to energy, hydrogen production, and low-cost material development for catalysis applications. So we are going to start our webinar. So over to you, Asif Hoja Saab. You can share your screen right now. Thank you.
Thank you so much to the SMEDA head office and the concerns. As the concerned person has introduced me, I am Asif Hussain Khoja, and I have done my chemical engineering from UTM. Recently, we are focusing on biomass as a potential feedstock for the combustion application, especially for the power generation. We are focusing on Pakistan and other developing countries as well. So if you allow me, I would like to share the slides and start the webinar officially.
Yes, so you can share your screen now.
Okay. It is visible to everyone.
Yes, sir, it is visible.
So today a talk is focusing on the solid fuel characterization for boilers feedstock as a feedstock. So today we would like to discuss brief introduction to the energy outlook as well as global and the energy mix in the world. Secondly, we would like to cover the coal and biomass energy generation globally, as well as we will see the Pakistan's perspective. The third component of the presentation supposed to be the boilers, the conventional boilers, but our concern and specification is not so much on boilers, but of course the problems arise in the boilers from long time, and the possible solutions, including the conclusive remarks. So we would like to start our presentation from the energy outlook of the world. So primarily we would like to understand that what kind of energy outlook and energy perspective and projection in those years in 2 centuries as well as the to the next century. If we see that primarily the fuel is up till now, if we are in almost in 2022 here somewhere, so we can see that the primary energy is being produced, energy is being generated through coal and oil and natural gas. If you see, these are the periods being categorized into, if you see the fuel wood is being used until the 19th century, and
We have internet issues, so kindly please be there.
Um, Please allow me to share the screen.
Yes, so you can share your screen now.
Sorry, the internet was just disabled due to some reason, I don't know. So we were discussing like in tertiary energy transformation, we can see that from hydrocarbons to the new energy sources. The new energy sources includes the renewable, and that is so-called golden age of new renewable energy, which is going to be transformed till 2050. But of course, we can see the share of coal and natural gas as well as the coal is not going anywhere. It is there, but the declination and the next energy demand will be fulfilled by the new energy era and the golden age by the renewable energy sources. So if you see that how the global energy demand being transformed, which is typically for the oil and gas, which is a metric ton of oil equivalent. If you see around the globe, we can see that some of the big circles which are explicitly telling about the energy demand in next 50 years. So if you see that Central Asia and South America is going to rise their demand to 70 metric ton oil equivalent, as well as you will see African countries, Middle East, India is going to be the big giant of the fossil fuel utilizer, as well as China is participating 790 metric ton oil equivalent. And Southeast Asia, if you see the blue, which is United States, Europe, and Japan, which is, you can see that negative, which means they are going to fulfill their energy demand by renewable energy sources. The first world country, of course, the third world country is definitely going to fulfill their, energy demand by fossil fuels. So India is one of the biggest going to be utilized to meet their energy demand through the fossil fuels. But United States, Europe, and the other part of the first world country is going to meet their demand by renewable energy. That's why they will be today there, if they are using, for instance, 100 metric ton, so it is going to reduce by minus 30, means they are not going to utilize their demand, but of course their utilization till date is going to rely on the renewable sources, and they are going to meet their energy demand through the renewable energy countries. But third world country is still going to meet their energy demand from oil and gas and coal. Of course, we are categorize them as a fossil fuels. So typically, the first world country is shifting. The paradigm shift can be seen in the United States, Europe, and Japan. They are going to shift for renewable energy resources to meet their energy demand. That's why they are in negative. Means today, if they are using 100 tons, for instance, so they are going to reduce by minus 30, minus 200. Means their demand today is not going to rise but decline by 2050. So that is the overall energy demand and the perspective of utilization of the fossil fuels. Consequently, we know that whenever we are using the fossil fuels, the CO2 emission is one of the critical issues in environmental perspective, as well as it is in any form of the climate change. It is polluting the world, and the natural phenomena are being affected due to the emissions of the CO2. If we see the current scenario, the energy consumption, and if you have seen in the previous slide, if you go with this pace, we are not, if we are not introducing any new policies for the sustainable development scenarios, so we will be progressing like this one. You can see in this graph, of course, we will be introduced some scenarios, but of course, it is going to be increased like this one. Not so much, exponentially, but partially it is going to increase because we are going to meet our demand by still fossil fuels. But if you want to improve, if you want to, meet our energy demand on the basis of sustainable development scenarios and to meet the UN's sustainable development goals, for instance, the climate change, achieve universal energy access, improve air quality. These three are the nexus of sustainable development scenarios. If we follow all these policies, which are surrounding by sustainable development scenarios, then we will be able to reduce the emissions in this perspective. So in any case, we have to look into the renewable sources and the renewable energy mix to the national and the global demand, so that we will be able to save our fossil fuels for the next generations, as well as we will be able to reduce the CO2 emissions on the objective of the Paris Agreement, as we have also signed this Paris Agreement as a Pakistan key player of, but our emissions are not more than 1% in the global share. But if you see current scenario, India, China, and the USA are the big players, and they are, the CO2 emissions globally is 65% from all those three countries. So it means they are not shifting towards the renewable energy sources, specifically United States of America, but China and India is gonna meet their energy demand through fossil fuels. That is a fact. So if we want to little bit understand about the coal, since our discussion is mostly based on the solid fuels and its preparation for the feedstock in power generation and boiler applications. So we would like to see the coal reserves of the world. So you can see that most of the coal reserves are in the United States, which is 237 billion tons, which is 26.6%. Russia is the second largest, having the second largest coal reserves, 157 billion tons, 17.6. Its share is, India has also 61 billion tons, 6.8%, and China and Australia has subsequently their share is there. But of course, we can see that other parts of the world has the coal, but not that significant. They can, push to some limit. We have our reserves, which is 286 millions of tons, which is very less, which might be less than 1% or less than 0.5% of the world reserves. So on that perspective, that of course these countries are going to utilize coal in any mean. There is a certain conventional utilization of the coal, as well as there are cleaner utilization of the coal. And that both perspective they are looking into. Let's just have a look into the global and regional, energy mix of, if you see that how Pakistan is, sharing their energy, primary energy. So we are almost, we have the 19% or maybe close to 20% of the energy in Pakistan is being generated by the coal-fired power plants. And if you see the world scenario, it is lie in between 25 to 27% of the world primary energy is being generated from coal. And there is another case that Mexico is also generating, but it is one of the cases they are generating very low energy from coal. So overall, Pakistan share in, primary energy mix in coal primary energy mix in Pakistan share is 17.42 as of 2022. But of course, it can be increased if we will able to exploit our existing resources. So if we look into the world power generation by coal, so nearly 36% of the world electricity production by source, which is coal. And if you see a very long distance, there is between the coal and gas, which is not more than 23%. And then there is a hydro, nuclear, wind, soil, other renewables, including biomass, solar, wind, and other forms of the energy, and oil. So the renewable share is supposed to be increased to some extent that we can meet our energy demand and we can, have the energy mix in the national and global need. So if we talk about the coal is being categorized into low rank, high rank coal. We will be a little bit talk about Pakistan as well. So in low rank coal, we categorize them based on the carbon and energy content usually, and the moisture as well. So if you see this diagram, it's not so complex, but it can be easily understandable. The carbon energy content, if carbon is increasing, this is a hard coal and it is the high quality coal, the energy content is higher and its applications are beyond the power generation. If you talk about the low rank coal, which is lignite, the carbon content is 20%, and subbituminous rank is 35 to 45% carbon content is there. But these two are, of course, being utilized for the power generation more, and of course, cement manufacturing and industrial use. But the hard coal, which is bituminous, greater than 65 to 85% of the carbon content, then their application is, of course, in thermal steam generation, as well as their application is in metallurgy and coke coal. And the anthracite, which is the world scenario, if you see, is less than 1%, which is one of the highest rank of a coal, which is being used for the industrial applications, smokeless fuel, and other domestic applications. So our application is mostly fall on the bituminous, subbituminous, and lignite coal. So power generation is being the feedstock for the power generation through coal is mostly these three types of coal will be dealt. So if you talk about Pakistan, out of the 286 million tons of the coal is existing in Pakistan, so that we mostly have the lignite in Thar, which is almost to 80 millions of tons. So which means it's because of the low carbon content and the high moisture content, it is quite difficult to utilize the lignite as a primarily feedstock for the power generation. That's why we are introducing some new technologies which are called underground coal gasification and gasification technologies. So subbituminous can be used for the power generation, but the consequences we are going to see in the next slides. Due to the, if you see a conventional coal-fired power plant, the coal supply is being introduced into a boiler. There are primarily there are two different types of a boiler we will discuss in later stages. But of course, if you are utilizing coal as a primary fuel, it is going to burn in a combustor, which is so-called boiler, where you are going to generate the steam to run your turbine, subsequently your generator, and produce the electricity, and it goes to the transmission lines. On the verge of this boiler, when you are combusting the coal in a combustor, it is going to emit carbon dioxide, SOx, NOx, and fly ash. Subsequently, the unburned carbon, which is so-called slake, and it is also called bottom ash. So these are the waste, are the some bottom ash and fly ash usually called byproducts, but of course their handling and their applications are of course a thing to discuss. But of course, SOx, NOx, and emissions. So what we need to do is we want to reduce those emissions, as well as there are certain problems with the boiler when you use the low-grade coal. Low-grade coal consists of sulfur and other metals and moisture as well, which create a lot of issues we will be discussing in later slides, the issues in the boiler. So this was the perspective of a coal global perspective and how it is being utilized for the power generation and how it is being introduced into the technology, which is called boiler technology for the power generation. That was for coal. Now we will be looking into the biomass potential. If you see the world perspective, that kind of, if you see Pakistan in the world perspective, so since we are an agriculture country, this graph depicts the per hectare, generation of the biomass. So we are nearly about 80 tons of per hectare. So we have a quite potential in the biomass supposed to be utilized. And the biomass is in the form of agricultural residue, forest residue, municipal solid waste, manure, and there are different waste which can be waste oils, of course, and the agriculture waste is one of the major waste in Pakistan, you can see. And this can be utilized as a primarily as the secondary feedstock for the power generation. If you look into energy mix by biomass in the global perspective, to introduce the biomass or to utilize the biomass, there are a few, objectives. The primary objective is to utilize the biomass, which is going to be waste in a while, to generate the electricity. Secondly, biomass is so-called carbon neutral. The thing is, if we talk about the seasonal plants or seasonal, crops, which are annually or biannually, completing their cycle, will gonna utilize, if you burn their waste, they are gonna utilize that particular CO2 for their growth. As we know, the process of the photosynthesis will utilize the CO2 and other SOxes and NOxes as the nutrients for their growth. So this is typically, when you use the biomass, it is typically so-called carbon neutral concept for the power generation. If we look into this graph, this is the global primary energy consumption by source. So in other renewables, of course, modern biofuels are also derived from definitely from biomass. And then you see that the coal and oil production is too much. Of course, natural gas is taking their part because of the huge reserves and the new technologies are being introduced. And the subsequent shares can be seen. So we can understand that we have the biomass and which has the potential to be used with coal or without coal as an independent primary fuel for the boiler applications. So if you see the renewable share, power generation by, and the other renewables and the nuclear, if you compare, nuclear is going to decline because of the certain, sanctions in the countries and their hazardous waste from the nuclear. So the renewables are most favored to generate the most likely by 2021, it is going to be, it has shared of greater than 25%. But of course, it's not enough for the energy mix to reduce the CO2 emissions and the consequences of the depletion of the fossil fuels in the modern industrialization. So typically, biomass power plants are quite similar and the same boiler technologies are being implemented. But before introducing into the boiler, we have some steps to process this biomass. First of all, the collection point of view, and then you have to grind it to make the particle size uniform, to introduce into the conveyor belt, and then introduce into the boiler. The boiler technology is quite similar, but the consequences, because of the biomass in the boilers are huge and bigger than the conventional coal. There are certain reasons for that. For instance, biomass, when you see the composition of the biomass, there are silicates, there is going to be magnesium oxide and other metals as well. These are going to create a lot of troubles in the boiler, and there are certain consequences you have to face. The first thing is you are going to compromise with your thermal efficiency, which is one of the most concern for the boiler to achieve the higher efficiency. Usually boilers are, the coal-fired power plant boilers are running at more than 85% of the efficiency. But when you introduce the biomass to the certain boilers without modification and without any certain amendments in the feedstock, you are going to achieve less than 40% of the thermal efficiency, which is quite, which is not acceptable for to such extent. And this is not going to be acceptable. We are going to have a lot of consequences. Why this is not being achieved as much as the coal? There are certain elements. The preparation of the feedstock and its characterization is one of the important components to understand before introducing into the boiler this thing. So we have to play here to understand the raw material characterization, characteristics, to generically accept it as a solid fuel in the combustion phenomena in the boilers. We need to understand the basics of that feedstock. So today our concern is more into the feedstock preparation and characterization, especially either this fuel is accepted as can be utilized as a feedstock, primary feedstock or a secondary feedstock in the boiler or not. So the preparation and the characterization of biomass or a coal is one of the most important components to understand before implementing, before introducing into the boiler applications. That's why we will be focusing on this part, that how a solid fuel is going to qualify for the combustion efficiency, better combustion efficiency. Conventionally, as we know that combustion process is, we are burning a fuel to via combustion process to produce heat and subsequently to generate the steam, and any fluid to be hot, any fluid to be to make the energy transfer form with the phenomena of heat transfer in the boilers to generate the steam or any heated medium, so that the energy could be transferred and the high temperature and high pressure steam gonna run your turbine. It can be any fluid rather than steam. So to complete a thermodynamic cycle. So usually boiler efficiency is typically understand that the heat output divided with the heat input. So heat in steam output, usually we calculate in kilocalories, and heat in a fuel input, what we are introducing. So how we are going to understand that this fuel is being like, if we calculate all those, if we characterize the fuel in primary stages, so we'll be able to understand the boiler efficiency is going to be one of the things we are going to achieve. So usually, typically, I'm not expert in the boiler industry, but of course, I will just give you the overview and the issues currently boilers are facing. So we have the two concepts of the boilers. Usually, there are a lot of boilers. There are various modern boilers which are might be different from those, and there are a lot of technology advancements with the passage of time. But typically, we are using two types of boilers, which is a water tube boiler where water is being circulated in a pipe where the furnace is, where the burning process is open and the stake is being connected and the hot gases are released, and that is on left hand side. So the other one is the fire tube boiler. The fire is being circulated among the tubes and the steam will be generated from the water tank. Then hot gases will be released from here. So these are two concepts. Whenever we are burning a fuel, here are the consequences. There will be like phenomena which you're going to see. So the most of the boilers, because of those feedstock are not prepared according to their needs, or with the issues because the preparation of the feed and its characterization is not typically an energy intensive process, but of course the feedstock treatment, primary treatment is energy intensive process. So that is quite difficult as well. That's why people are just introducing the coal as it is, just reducing the size, meeting the particular technology and implementing into the boiler. So we can see that there are certain phenomena which is called slagging inside the boiler. We can see the fouling inside the boiler. There is agglomeration. This is because of the feedstock. As I said, there is a sulfur in coal and certain other elements possibly in the coal, metals in the coal, as well as if you talk about the biomass, there is iron, there is sulfur, there is magnesium, aluminum. They're going to stick to the walls and create agglomeration and fouling. Consequently, if your boiler heat transfer is not uniform and not being achieved as to be achieved, that is going to create a lot of problems in your thermal efficiency, as well as the boilers are going to choke, and it's quite difficult to clean up the slagging. The boilers are water tube boilers to be cleaned from inside. It is quite hectic and energy intensive and cost intensive process. So what could be the solutions for this particular problem? There will be a lot of solutions technically, but of course we will be talking about on two perspectives. The primary perspective is technological advancements, designing of a new boiler, new combustors for biomass and coal, and then there is a process system optimization, which is usually done by the engineers, boiler engineers in the plant industry. But of course, designing of a new boiler required a lot of time, a lot of money, a lot of technical skills, and of course, process optimization. If you are doing through hit and trial or any, for experimental process optimization, through a dynamic process optimization technique, it is quite energy intensive process. So the other perspective, other approaches to improve the boiler efficiency is the feedstock modification and treatment. The feedstock, as we know, that is coal. And if we talk about the solid fuels, we are in this lecture, in this discussion, we are solely focusing on the solid fuels. So feedstock modification treatment is one of the approaches that is not so energy intensive, but of course it can be primarily, it should be done before the designing of the boiler. But if you have already done the boiler, you can also tweak your feedstock modifications according to the need of the boiler. So there are two concepts. One is modification of the feedstock through blending, means we have a coal, we have a biomass, we can approach with different blending ratios. If we are using 80% coal, we can use 20% biomass. It comes with it comes with an investigations and which kind of ratio is more suitable. That's what we're going to talk about. And pre-treatment of a feedstock for the available boilers. The pre-treatment in terms of size reduction, removal of the moisture, and maintaining the gross calorific value which is required for the boilers. So our approach is mostly based on the modification of the feedstock and the blending ratios for the available industry. So what will be the characterization techniques? What are the characterization techniques we should focus before implementing in as a feedstock in a boiler application? What kind of preliminary characterizations to be done to make a fuel called a qualified fuel for boiler applications? Primarily, these are not just lab scale applications, but of course, industry is usually practicing it. The qualified industries are practicing, but mostly they are doing XRF analysis and gross calorific value. They mostly do these kind of understandings, this kind of techniques to understand the requirement of a fuel. But as an academician, as a little bit of understanding in solid fuels, we feel like the scientific community feels like the feedstock should be characterized thoroughly, so that at the end of the day, so we would be understand to say it is qualifying as a feedstock with the evidence of the characterization. So primarily, any fuel, suppose either it's coal or biomass, we have to see its ultimate and proximate analysis or the gross calorific value. These three are primarily to investigate how much carbon, hydrogen, nitrogen, and sulfur is present in particular fuel, as well as how much volatile matter is there, moisture content is there, and ash content is there. So all these elemental analysis and proximate analysis will help you to understand how it is going to behave when it is going to for the combustion process, and of course fixed carbon and gross calorific value. If there is a range for the carbon to be range of a carbon, hydrogen, nitrogen, and sulfur to be qualified as a fuel, as well as volatile matter is independent, you cannot say it, but moisture supposed to be in that particular limit, which is being defined by various standards. I'm not talking about those standards, but of course, I'm just giving the basic perspective to that characterizations. And ash content. If for a certain fuel, it has a more than 40%, 50% ash, you are using as a primary fuel, it is going to create a lot of issues. Since the 40% ash is not going to burn, means your waste, bottom ash, which is called slag, which is unburned, is going to be 40%. If you have introduced 100 kg, 50%, yani 50 kg of your waste, how are you going to handle it? So it is going to be a very challenging to handle these kind of waste in the industry, and their applications are also limited when it comes to the biomass bottom ash. Fly ash is of course one of the we call it a byproduct which can be used in a variety of applications. At the end of this discussion, I will also explain a little bit perspective of the fly ash implementation in modern technologies, as well as the bottom ash treatment and recycling. So these are the primary techniques that how we can do the elemental analysis. We have different set of we have different set of equipments to do the such experiments for proximate and ultimate analysis. And of course, there is a bomb calorimeter with the international standards is there to understand and to analyze the gross calorific value of particular fuel. It applies for the both coal and biomass. Okay, so on the verge of on the perspective of the blending, if you want to mix the energy, like we want to mix coal with biomass, for some reason to make the energy mix to reduce the CO2 emissions. As I said, the co-combustion phenomena I will discuss later as well, but the co-combustion phenomena is to reduce the CO2 emissions as well as to for the energy mix perspective. So in both perspectives, you can utilize coal. So coal has the high calorific value, biomass has the lower calorific value. So you can maintain in a way that there will be no compromise with the calorific value to some extent, as well as you're going to reduce the CO2 emissions, which is one of the most important components, as well as you're going to reduce the ash content as well, because biomass have you can tweak it to the better carbon hydrogen to carbon ratio. So the third is FTIR, which is a very primary characterization, which is usually defined to understand the functional groups and chemical bonds. So we have a coal. What is the interaction? How are the elements interact each other, carbon, nitrogen, and hydrogen? When it comes to the biomass, how the CH groups are interacting. This is one of the important characterization to understand the behavior of the combustion. Later, we are discussing the thermogravimetric analysis, which by using the thermogravimetric analysis in air environment, we will be able to quantify, we will be able to, simulate and understand the thermokinetic behavior and the combustion performances of that particular fuel, which is one of the important techniques being practiced from um, uh, many years. But of course, recently, the advancement in AI and the optimization techniques, this is one of the phenomena to be understand by the industrial for the industrial application of any kind of a solid fuel. So one of the important techniques is thermogravimetric analysis using the air environment, and the same environment you are producing in the air, like in the combustion chamber, which is called boiler. So in that particular scenario, you are going to investigate the thermokinetic behavior. So whenever there is a combustion, there are thermokinetic behavior of the study. There is a thermodynamics behind this, because you are gonna see how much the combustion process has the combustion phenomena, either it's a devolatilization or the char formation. There is the activation energy involved. There is a thermodynamics, which has the entropy, gives free energy, and other forms of energies are involved. So you need to quantify that, how it is going to perform, and how we can lower the activation energy so that the combustion process will be smooth and the high temperature will be achieved. So that is typically connect to the X-ray fluorescence, which explains about the composition of the elements. And further, you are going to analyze the fusion of that particular ash or the biomass. Feedstock can also go through the ash fusion analysis, where you will be able to understand what are the slagging, fouling indices, what is its potential to be slagged, to be fouled in the combustor when it comes to the combustion. So, for instance, we have investigated, recently we have investigated, this is the unpublished data. We have I'm talking about for ultimate analysis, not proximate actually, but because we did not have the data for the volatile matters as content, moisture content, and fixed carbon. But of course, we have investigated for carbon, nitrogen, and sulfur. We have blend two biomasses, which is wheat straw and hemp, wild hemp, which is all around, you can see in various parts of the country. So we mix those, we make the different blends. We keep the parent fuels like hemp 100 and wheat straw 100, but we make different ratios and investigate it, the carbon, how the carbon content is going to be balanced, how the hydrogen content is going to be balanced, how the nitrogen, and how the gross calorific value. With that, it is going to be changed, the whole kinetics, thermodynamics, and the combustion process of that particular blends, so that we can understand that ultimate analysis is one of the important techniques to make a fuel qualify for other techniques, such as thermogravimetric analysis for the combustion, as well as the ash fusion analysis. So usually thermogravimetric analysis is being used, the data is being used. Primarily, we are creating an environment, same like in a boiler, in the TGA equipment, and we run till the first fusion temperature. So we try to understand the minimum temperature to be gained and the behavior of that particular fuel. In terms of, if you talk about blends, there will be a synergetic effect as well. I will discuss this part, but there will be kinetics, and from this kinetics data, we can understand the thermodynamics of that particular fuels. So for the combustion performance, we can also through this characterization, we can also analyze the induction index, burnout index, combustion index, and flammability. So these are most important parameters to understand from the primary characterization and this calculation data to make a fuel qualify for the combustion phenomena. So when it comes to the kinetics, there are various kinetic models available, and there are various model free and model fitting kinetics is available to simulate it, to vary the heating rates, and to make different ratios, and to understand their combustion behavior in a controlled environment, like not exactly like a boiler, but quite like a boiler, and understand the thermodynamics and kinetic parameters. From that, we can also understand the combustion performance of that particular fuel through this characterization. So as I have explained that X-ray fluorescence will tell you the elemental composition in the feedstock as well as the ashes. Once your fuel is burned in the TGR in any combustor, of course you can do the emission analysis. This is a different phenomena, but of course we are more concerned to the fuel. So the elemental composition is going to be used to calculate the base to acid ratio, which is going to be, a key part of slagging, fouling, and bed agglomeration index. And this is a solidly, connect you to your boiler performance as well as the age fusibility index. So age fusibility index can also be calculated through the age fusion analysis, which is going to determine the fusion temperature in oxidation and reduction environment to study the fouling through the 4-stage of a temperature blend. So once you have the age after the combustion in the TGA, you can do the age fusion analysis, which is one of the important characteristics to understand the highest achieved temperature by any fuel before introducing into any combustor. So these are the techniques going to help us to understand the characteristics of a fuel to be qualified for boiler applications. So age fusion analysis, after the combustion, you have the age. Of course, you will have the age. That age will be, going through the age fusion analyzer, and you are gonna predict those temperatures, which are very important. So the combustion performance analysis using the XRF data, which is slagging index, based on the base to acid ratio, fouling index, you can check based on the sodium and potassium. Age fusibility index, of course, initial deformation temperature, which is going to come from the age fusion analysis, hemispherical temperature, which is also going to become from the age fusion analysis. In later stages, we're going to discuss this. Of course, bed agglomeration index, how much the mass is being agglomerated in the bed of the during the combustion, either it's fixed bed combustion or the movable combustion. So with looking into all these perspectives, what we need to understand is there is a phenomena of co-combustion of coal and biomass. So while looking into those characterizations, we can blend coal with biomass while doing all these characterizations and to make it qualify for the co-combustion. The same phenomena and same characterization will be applied, and of course co-firing is going to help us to reduce the CO2 emissions, as well as we can achieve the favorable conditions in while producing more biochar and the more gaseous products, because of the biomass have the greater carbon to hydrogen ratio. And of course it is going to be helped by the coal as well, because of the high gross calorific value, and this gonna give you a perspective of the energy mix, while biomass and coal can be integrated in a way and can be investigated and qualify for the co-combustion, which you are going to have the certain benefits of the low CO2 emissions because of the share of the biomass, as well as biomass has the low calorific value, and of course it has a more slagging, fouling, and other indices. So coal is going to help biomass in a way, and the biomass is going to help in carbon to hydrogen ratio. So with these blends, we can achieve a synergetic effect. Like for instance, some people are believing like 1 + 1 is equal to 3. Technically, it is possible. Mathematically, I think it is not possible, but technically it is possible, because if two people are working together, one has a certain, certain qualities and other has a certain qualities, when both are combining each other and they give synergism to a part, so certainly the coal and biomass are going to be contribute with those ways and bring a new perspective and addition to these performances that is defined as the synergetic effect in this co-combustion phenomena. Moving to next, we see that the age fusion analysis. Once you have characterized your fuels burn in the combustor and in the TGA, and you have your ashes from those characterizations, those ashes supposed to be have the analysis that from the ashes we can predict the performance of the boiler. For instance, in this case, this is a biomass fly ash, which has a certain original temperature, deformation temperature, spherical temperature, and hemispherical temperature and flow temperature. This temperature is one of the important to achieve the maximum temperature in the boiler. So if you see biomass fly ash shows almost 200 degrees C of fusion temperature, and if you see coal is achieving almost 1300 of fusion temperature, meaning coal has the higher fusion temperature, flow temperature than the biomass. So when they are integrating in different ratios, you can see that the certainly fusion temperature or a flow temperature has been increased to that level where we can compromise with a ratio and achieve this particular while integrating the 50% of biomass into the coal. So the share of a biomass will be determined a certain characterization technique, and of course with the ash fusion analysis. So we'll predict the boiler efficiency with the temperatures we can achieve maximum in the boiler. So of course the temperature is important thing which is going to be generate the steam or going to heat any medium which is going to run your turbine in any case. So that's why the fusion analysis is one of the important techniques. Your ash is supposed to be quantified, your ash is supposed to be supposed to be investigated before getting into the utilizing into the as a feedstock for the boiler applications. So that was a brief overview for the characterization techniques for feedstock to be qualified as a fuel in the boiler efficiency. On conclusive remarks, I could say that the feed characterization technique is one of the economical approaches to achieve the better boiler and plant efficiency. That the reasons I have already explained what kind of investigations you can do before utilizing a fuel to be qualified as a fuel. So the second part is we can also bring the co-combustion phenomena of coal and biomass so that the emissions to be lowered, as well as the higher thermal efficiency will not be compromised. And of course, the energy mix phenomena as will be there. On the basis of the characterization, you can achieve the optimum blends in providing a huge potential in both experimental and theoretical approaches. Of course, coal has a greater fusion temperature and lower slugging and falling index. So making a co-blend of biomass with coal will improve definitely the thermal efficiency, as well as it is going to reduce the slugging falling tendency of biomass and to make a qualified fuel for the boiler applications. So this is from my side. Now the floor is open for the discussion. So I would like to take comments from your side, as well as if there is any question I can answer. So definitely I would like to.
Ji, thank you so much. Thank you so much, sir. It was really a wonderful presentation given by you. And now I would like to invite anyone. If anyone have question, you can ask in Urdu as well, because I know some of industrial professionals are here in this meeting, and they are hesitant to talk in English. So अगर किसी का question उर्दू में भी है तो वो पूछ सकते हैं, वो रेज करें.
जी जी बिल्कुल हम डिस्कशन उर्दू में ही करना चाहेंगे. It's informative to speak in English in the presentation, but of course I would like to answer in any language the participants want.
So if anyone has a question, you can ask. Sir, it's a question from Umar Fiaz. He's from Sapphire Finishing. How using a combustion of biomass and coal in boiler is sustainable? Also, there are seasonal variation in biomass. How we will deal with it?
अच्छा, इस सवाल को रिपीट करें जरा, वो थोड़ा सा मुझे समझ नहीं आया.
एक मैं इसी क्वेश्चन को है ये चैट बॉक्स पे पोस्ट कर देता हूं.
पोस्ट कर दें बेशक. if some मैं क्वेश्चंस देख रहा हूं. if anybody wants to post the question, please post करें. it will be easy to answer and make a discussion. How using a combination of biomass and coal in boiler is sustainable. Also, there are seasonal variations in biomass. How we will deal with it? That's a good question. That's the primary issue we are discussing with. Primarily, we are keeping in current scenarios, we are keeping coal as a primary fuel and biomass is an additional fuel. मतलब अगर हम 20% या 10%, 15% की blends prepare करते हैं while keeping the calorific value same, उसके लिए थोड़ा सा प्री ट्रीटमेंट का है कि you have to prepare the biomass in the pre-treatment section. You have to keep the uniform ratio कि आपकी पार्टिकुलर टेक्नोलॉजी इतनी अच्छी होनी चाहिए कि वो क्वालिफाई कर सके कोल के साथ ब्लेंड बनने के लिए फर्स्ट स्टेज पे. सेकंड स्टेज पे अगेन वी हैव टू इन्वेस्टिगेट दैट द बेसिक रिक्वायरमेंट ऑफ द कोल इज लाइक क्लोरिफिक वैल्यू जो रिक्वायर्ड है किसी भी फ्यूल को क्वालिफाई करने के लिए वो पूरी है कि नहीं है. एंड थर्ड वी हैव टू इन्वेस्टिगेट ऑफ कोर्स the perspective of the characterization is there. We can make an investigation through the different characteristics and make it qualify. और मैंने कमर्शियल पर्सपेक्टिव ज्यादा इन स्लाइड्स में नहीं किया, थोड़ा सा एकेडमिक पर्सपेक्टिव रखा है. ऑफ कोर्स इसमें बायोमास कोल ब्लेंड के प्लांट्स कमर्शियली भी अवेलेबल हैं. दे आर कंप्रोमाइजिंग विद सम ऑफ द एफिशिएंसीज और उस एफिशिएंसी को वो थोड़ा CO2 एमिशंस और CO2 emissions plus the renewable energy mix से जो है ना वो equate कर रहे होते हैं. So still there is a potential. Seasonal variation के हवाले से when you are preparing the feedstock, the most important is making the size applicable to the boiler as well as maintaining the gross calorific value. तो वो आप रेशियो को ट्विक करके कर सकते हैं. Even though if you are blending 5%, that's supposed to be meet your basic requirement. कम से कम रेशियो पे आपको इतने इश्यूज नहीं आते हैं. There are commercial plants operating in Germany, Sweden और कुछ साउथ अफ्रीका में भी अभी इंस्टॉल हुए हैं. तो दिस फिनोमेना, बट ये क्वेश्चन वहां पे भी जो है वो क्वालिफाई होता है कि व्हेन इट कम्स टू द प्योर बायोमास बेस्ड पावर प्लांट्स. तो इफ यू सी पाकिस्तान के अंदर भी कुछ कमर्शियल एंटाइटीज ने बायोमास बेस्ड पावर प्लांट्स लगाए हैं. मैंने विजिट भी किया है. ऑल दोस प्रॉब्लम्स दे आर फेसिंग. वो सिर्फ ग्रास क्लोरिफिक वैल्यू देख रहे हैं और बाकी कोई भी इन्वेस्टिगेशंस उनकी नहीं है. देयर वाज अ लॉट ऑफ मॉइस्चर इन द फीड स्टॉक व्हिच क्रिएट अ लॉट ऑफ इश्यूज लेटर स्टेजेस. और दूसरी बात, कार्बन टू हाइड्रोजन रेशियो हम मेंटेन नहीं कर पाते हैं फीड स्टॉक में, जिसकी वजह से वो प्लांट जो मैं जाहिर है ये देयर आर अ लॉट ऑफ स्टेक होल्डर्स, सो आई वुड नॉट take the name of that particular biomass based power plant. I personally visited and investigated a lot of things about the feedstock. I'm not a boiler engineer that I would not comment on that, but I know the issues inside the boiler. So biomass में ज्यादा problems हैं अगर आप solely as biomass को use करें, but coal के साथ अगर आप little ratio में blend करते हैं 20% तक, so these issues can be minimized through the brief investigations at the first stage before designing. Or particular design variations definitely I have seen in the mechanical engineering magazine that there are certain modifications required when you want to blend it to make it optimum output. So I think I have tried to answer your question. You mentioned CHN analysis of biomass. What results of CHN analysis show that the biomass is good for combustion? What ratios of CHN qualifies it as a fuel? So primarily CHN itself तो कोई ऐसी टेक्निक नहीं है जो कि उसकी क्वालिफिकेशन, बट ऑफ कोर्स कार्बन एक मेजर आपके पास एलिमेंट है जो कि आपकी किसी भी फीड स्टॉक. अब लेट्स टेक द एग्जांपल ऑफ कोल कैरेक्टराइजेशन. प्राइमरली हम कोल के ग्रेड को कैसे मेजर करते हैं? कोल के ग्रेड को हम प्राइमरली हमारे पास कुछ इन्वेस्टिगेशन हैं. सबसे पहले हम उसका कार्बन कंटेंट देखते हैं, ठीक है. दूसरी बात जो है वो हम उसका सल्फर देखते हैं ताकि हम सल्फर को आगे कनेक्ट करेंगे एज फ्यूजिबिलिटी इंडेक्स के साथ और एज फ्यूजन एनालिसिस के साथ. इसके बाद नाइट्रोजन और हाइड्रोजन है. कार्बन टू हाइड्रोजन रेशियो इज इम्पॉर्टेंट. जितना मैक्सिमम हो इतना अच्छा है ताकि कंबस्टेबल प्रॉपर्टीज अच्छी हो जाएं. तो कार्बन ही वहीं आपके पास बुनियाद है जहां पे आप किसी फ्यूल की कैरेक्टराइजेशन करते हैं. फॉर इंस्टेंस हम कहते हैं एंथ्रासाइट है. ऑन व्हाट बेसिस वी आर सेइंग इट्स एंथ्रासाइट? इट्स द कार्बन. मोर देन 85% किसी भी टाइप ऑफ कोल में है तो इट इज एंथ्रासाइट. अगर 65 to 85 की विंडो में कार्बन मौजूद है तो इट इज क्वालिफाई एज बिटुमिनस कोल. 35 से 45 या अबव 45 to 64% है तो वी सब बिटुमिनस की कैटेगरी में आएगा. उससे नीचे लिग्नाइट जो कि पाकिस्तान के मेजॉरिटी ऑफ कोल में है। तो इसी तरह से हम इसको बेसिक अंडरस्टैंडिंग ला सकते हैं। और रेशियोज नाइट्रोजन और sulfur की minimization is one of the important components during the preparation of the feedstock. Apply for both, स्पेशली सल्फर के लिए कोल की डीप क्लीनिंग का कॉन्सेप्ट है जहां पे आप सल्फर को रिमूव कर सकते हैं, बिकॉज देयर आर सम रिस्ट्रिक्शंस एज यू ऑल फ्रॉम द इंडस्ट्री एंड मोस्ट ऑफ यू इज वेरी वेल अबाउट द पॉलिसी ऑफ द वर्ल्ड अबाउट द रिमूवल ऑफ द सल्फर डाइऑक्साइड एमिशंस जो ग्रीन हाउस गैसेस की हैं। तो उन लिमिटेशंस को भी मीट करने के लिए व्हाट यू नीड टू डू इज यू नीड टू एनालाइज द सल्फर कितना है। So then once you have all those characterizations, you can qualify for certain certifications। जी हम जो फीड स्टॉक यूज कर रहे हैं उसमें सल्फर की क्वांटिटी इतनी है जिससे हम पॉसिबल एमिशंस इतनी है। ऑफ कोर्स एमिशन एनालाइजर्स हैं जो डेफिनेटली कर सकते हैं, बट इट इज इंपॉर्टेंट टू रिड्यूस इन द प्राइमरी स्टेज, यानी फीड स्टॉक के दौरान आप इसको रिड्यूस कर सकते हैं थ्रू डीप क्लीनिंग एंड अदर प्रोसेसेस। There are main ways to co-combustion. One is separately burn each fuel with different burners. Other is blending, which will have the high efficiency. पहली बात तो ये है कि इसमें मैं 100% I'm not sure about it. I will not say कि कौन सी better है, but let's calculate from the basic understanding. If you are separately burn the fuels, coal has the higher efficiency. We know that the SOxes and NOxes will be a little bit higher. But when you burn the biomass in a different chamber, it will has the consequences with the boiler. If you are not, the designing is not up to the mark for the boiler. Germany के boilers हैं, पाकिस्तान में install हैं, they are getting 25% thermal efficiency. Coal के 85% से above है. All the people who are from the industry know it. So separate में I'm not sure about what we are getting. But when you are blend it, there are something coming out from biomass जिसके carbon to hydrogen ratio maintain करने में help करेगा। और high fusion temperature of the coal will help to rise the temperature bar. So इससे एक synergetic effect theoretically भी calculate किया गया है, experimentally भी calculate किया गया है, जो achieve कर सकते हैं। That is in my knowledge, but the separate I'm not sure about it. So how CO2 emissions will be less when combustion of coal and biomass? अच्छा, थोड़ी सी myth है, but we need to understand from the basic point of view. Coal or bio, let's take the example of कोल 10% 90% है, 10% बायोमास है। मैं कहता हूँ आपने 10% emissions कम किए हैं। I have a logic behind this. For instance, if you are burning biomass, seasonal biomass, आपका wheat straw है या rice husk है या any of the seasonal agriculture crop का है या biomass का किसी भी source का है, तो it's seasonal. Next year जब वो grow करेगा तो it required CO2. The emissions you have made while its combustion will be utilized is a primary source for its energy, like in photosynthetic based plants I'm talking about. तो वो इतना ही यूटिलाइज होगा जितना उसकी ग्रोथ के लिए चाहिए होगा। तो दैट ब्रिंग्स द कार्बन न्यूट्रल कॉन्सेप्ट इन बायोमास। तो 10% जो आप बायोमास का ब्लेंड करेंगे तो इट विल डेफिनेटली रिड्यूस द 10% ऑफ द CO2 emissions. I think I have answered the questions which are being slide. Agar if somebody wants to ask any of the things.
Yes, sir. We have a question from Hamad Gohar Saab. Ask what qualities should be in biomass that show the type of biomass that are good for combustion in the boiler?
What qualities should be in the biomass and that it is qualified as a biomass? Primarily, we will definitely look into the two main things. One is the carbon. Ultimate and proximate analysis so will be quantified as biomass in a range of a carbon. Then we will look into the gross calorific value. Carbon will determine automatically the gross calorific value. So once we have understand the gross calorific value is in a range where it is required to achieve a certain temperature, and of course the ash fusion analysis will help to understand. That's why I emphasize on those characterization techniques, primary characterization techniques to qualify as a fuel. So because of the gross calorific value and carbon content, and of course its combustion behavior explicitly explain you, either it's going to be achieve a higher fusion temperature, which certainly give you the rise in the steam generation, definitely is going to be qualified. Let's take example of wheat straw and rice husk. Rice husk के अंदर silicates बहुत ज़्यादा होते हैं. It is one of the main reasons in the agriculture जो mixed biomass होता है उसमें राइस हस्क एक मेन कंपोनेंट है जिसमें सिलिकेट्स बहुत ज्यादा होते हैं, तो एग्लोमरेशन का कॉन्सेप्ट, स्लैगिंग का कॉन्सेप्ट इस वजह से ज्यादा होता है. when it comes to bagasse, uski bahut high efficiency hai, it is not going to create a lot of agglomeration because of the non-cellulosic behavior. अच्छा, CO2 emission will less in combustion, ये हो गया. What qualities should be in the biomass that I have tried to answer? I'm not sure about if you are satisfied or not. You can ask again. If someone wants to install biomass-based boiler, what steps, test indicators should be checked to measure to have an efficiency more than 80%? Is it possible to have the efficiency more than 80%? Biomass ke liye, I'm not sure. Up till now, the achieved efficiency by German scientists is more than 45%. That's why the blending concept is more, superior than the just standalone. कुछ ऐसे स्मॉल स्केल बॉयलर्स हैं जो 65-70% तक एफिशिएंसी में जा सकते हैं. अब आप बात कर रहे हैं कि कौन से इंडिकेटर्स को देखा जाए. सिंस आई एम नॉट a right person to ask about a plant कि इस पूरे एक प्लांट को कैसे कॉन्फ़िगर किया जाएगा. इट्स ए क्वाइट बिग क्वेश्चन. बट ऑफ कोर्स अगर आप किसी भी बायोमास को फीड स्टॉक को बिहेवियर देखना चाहते हैं, फीड स्टॉक को बुनियाद बना के अगर आप बायोमास इंस्टॉल करना चाहते हैं, तो फर्स्ट ऑफ ऑल द अवेलेबिलिटी ऑफ फीड स्टॉक इज द कैरेक्टराइजेशन, द सेग्रीगेशन ऑफ द फीड स्टॉक. जो आपके पास ब्लेंड पॉसिबल बनेगा डिफरेंट बायोमासेस का, उसका प्राइमरी इन्वेस्टिगेशन. On the basis of those investigations, you can order to a designing company to design a boiler. ठीक है, variation seasonal आती हैं, then you need to compromise in some point of efficiency as well. But अगर आप blend बनाते हैं तो you are little bit, you have the flexibility with the variation in the biomass, because you are going to only look into the carbon and gross calorific value. So that is my point of view regarding the feedstock to a designing perspective. अब वो design कैसे करता है, it's a very different vast question, and I'm not a boiler engineer, so I'm not designing engineer, so I can answer your question for a whole plant. But primary investigations should be there on the basis of your available data, the feedstock you have available in the region. ये बहुत जरूरी है कि आपके पास एनफ फीड स्टॉक हो. ऐसा ना हो कि आप 100 मेगावाट का प्लांट इंस्टॉल करें और साल में 6 महीने वो बंद रहता हो. So you need to prepare accordingly. Silos and different concepts and preservation of the feedstock, you can do it. It's not so hard science. Can we use co-combustion in every type of boiler? No, you cannot do in every kind of a boiler. It is not recommended. लोग कर रहे हैं. ये chain moving grade boiler हमने पंजाब में install देखा है. They have a lot of consequences because they bring a plant design for Germany, and Germany feedstock and the environmental conditions and other things are different than Pakistan. So we need to see the designing perspective. So most of the questions are on the designing perspective, but I will happy to answer based on the feedstock perspective. Any other type of modification required to burn the mixed fuel? The modifications are usually required in the feedstock investigations, removal of the moisture, and its uniformity to introduce the feedstock is one of the important components to be considered before any modification. Once you have all the calculations, all the possible data for your feedstock, then you can accordingly, a design engineer can modify your boiler according to the perspective of your feedstock. How coal reduces slagging and falling of biomass? अब अगर हम स्लैगिंग एंड बॉइलिंग का बायोमास का अगर उस स्लाइड को देखें, let me bring you there. Give me a minute. देख लो इसको to understand करने के लिए. स्लैगिंग और फॉलिंग इंडेक्स यूजुअली डिपेंड करता है सल्फर और sodium. Falling index, especially falling index usually depends upon the sodium and potassium content. Sodium और potassium content typically coal में कम होता है, but we can debate on the sulfur content कि slagging को कैसे कम करेगा, because it is coming out from sulfur. So via deep cleaning we can reduce the sulfur content from the usually it is being done, but most of the power plants are not doing it, but of course you can reduce it. But typically falling index can be reduced, and ash fusibility index will definitely reduce because of the high temperature achieved in the feasibility studies. So that's why I said that it can reduce the falling index. Slagging index is quite debatable, that both of them have the low sulfur in some cases when it comes to the bituminous coal. We can debate on the slagging, but falling is definitely depend upon the potassium and sodium content. So definitely coal is going to reduce in the co-combustion phenomena. Slagging, yes, some of the coal have the high sulfur content, so it is not going to help, but it can be otherwise as well. If some part of a some type of a biomass have a lower sulfur content, it can also help in reducing the slagging index. It can be otherwise. It is debatable. If you have any questions, I would like to answer. किसी की कोई हमसे भी कोई share करना चाहता है, we still have some time, so we can we can discuss. किसी का कोई idea है and anything like.
सर आई थिंक अभी कोई क्वेश्चन नहीं है किसी तरफ से, जो भी क्वेश्चन थे वो एड्रेस कर दिए गए हैं। सो वंस अगेन बड़ी अच्छी डिस्कशन हुई आज इस टॉपिक के लिए, लेकिन और आई होप के काफी इंफॉर्मेशन मिली होगी जिसको स्पेशली फॉर फीडस्टॉक कैरेक्टराइजेशन के लिए। सो आई थिंक it's all from our side. Thank you so much, Asif sir, for your time. And
I would like to add one thing. If the stakeholders feel like if there are still questions, they want to collaborate for anything specifically based on the feedstock investigations, we are always available to the industry. We can talk about it. We can bring our knowledge to the industry and take their knowledge and make a synergetic effect to progress for the better future of Pakistan. And thank you so much for SMEDA for organizing this workshop. And I'm grateful. Thank you. Thanks for all participants as well.
okay, thank you. Allah Hafiz.
Allah Hafiz.